Now that we have all of the sides and angles that we need, we will go straight ahead and find the area of the figure. As a matter of fact, we suggested that we might be able to do that in 3 different ways. Therefore, if this one seems to be too cumbersome, then we have other methods that we are going to demonstrate which will maybe be a little bit more efficient in finding the area of this figure. Finding the area of PQRS may be done by adding the area of the 2 triangles. We have the 2 triangles. On this occasion, we are treating the figure as if it is separated into 2 triangles. For the right-angled triangle, we may say that area is equal to half base times height, which is our traditional and easily remembered way of finding the area of a triangle. You ask, what's the area of the triangle? Immediately, half base times height. We can use half base times height on this occasion because the base and the height are perpendicular to each other. The base and the height are perpendicular to each other. Let us use the perpendicular sides. So we will use the perpendicular sides and we will say that one is the base and one is the height. It doesn't matter which is which because we are going to be multiplying and we know that the order in which we multiply does not affect the product. And that is known as the commutative property of multiplication. Those are the 2 perpendicular sides of the right-angled triangle, which may be used as the base and height. The height, we choose to say that it is 6.9 centimeters, and the base, we choose to say that it is 4 centimeters, and it doesn't matter which we choose as which. The result will be the same. Now, what do we have there? You can easily see that half of 4 is 2, and then we multiply 2 by 6.9. An easy way to do that is to multiply 2 by 7 and you will get 14. And then you're going to think about subtracting in order to make an adjustment. You will get 13.8. So that will be, I hope I'm correct. Yes, I'm correct. 13.8 centimeters squared or square centimeters. Now, what about the other triangle? The other triangle is neither right-angled nor has a height which is perpendicular to a side that we can call the base. So let us say that again. It is neither a right-angled triangle nor does it have a height that we can say is perpendicular to any of the sides which we may consider to be the base. Area of a triangle equals half the product of any 2 sides times sine of the angle that the 2 sides form. Area is equal to half AB sine C. Area is equal to half AB sine C. What does that mean? A and B will be any 2 sides of the triangle. A and B will be any 2 sides of the triangle. And what is C? The angle that is formed by those 2 sides. Area is equal to half the product of any 2 sides times sine of the angle that the 2 sides form. We will demonstrate that highlighting them in red. The 2 sides that we are using on this occasion are the 8 centimeter side and the 8.5 centimeter side. The angle that those 2 sides form is the 30 degrees angle. Therefore, these 2 sides will be substituted as A and B in any order, and the angle is 30 degrees. So 8.5 takes its position first, 8 will take the second, it doesn't matter the order, and then the angle that the 2 sides form is 30 degrees. With sine 30, now sine 30 is equal to a half. what do we have? A half, because we are just picking this thing out in an easy to use manner. So we have sine 30 is a half. So a half of 8 is 4. And then we have another half here. A half of 4 is 2. Therefore, in the end, we'll just have 2 to multiply by 8.5. And we may say 2 to multiply by 9. 2 nines, 18. And then we can think about removing the 2 halves, which will be 1 whole, and then we'll get the result. So 2 nines, 18, and we are going to remove 1 whole. We can do that calculation in our brains. We can do it mentally without having to write anything down. And that turns out to be 17 square centimeters, or we may say 17 centimeters squared. Finally, the area of the figure is the sum of the areas of the 2 triangles. We have triangle 13.8 centimeters squared, and the other one is 17. When we put those together, we have an area of the entire figure of 30.8 square centimeters, or we may say 30.8 centimeters squared. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.